Welcome everyone, this is Neil from Edureka and today we'll be talking about what is Java. Now you must all have heard about Java from either your colleagues, your friends and must be wondering what it is and what it is going to be used for. That is exactly what we're going to be talking in today's session. So let's not waste any time and let's move forward to today's agenda. So we'll start off by first understanding what Java is and where it is going to be used. Then moving forward, we'll be discussing about the various features of Java and the Java environment. After that, I'll help you understand how Java works, and then we'll be deep diving into Java by discussing the various data types, the operators, as well as functions in Java. Finally, towards the end of the session, we'll be talking about the object-oriented concepts in Java. Now, to those of you who do not know what object-oriented concepts are, this would be a good insight to that. So, any questions with respect to today's agenda? Alright, Varun says he's clear, so is Deepak, Rachel, Emily, Stephen. That's great to see, guys. So without wasting any time, let's move forward and discuss the first topic, that is what is Java. Now, Java is a programming language that was created by a team led by James Gosselin in 1995 for Sun Microsystems. Now, to help you understand better, the need for creating a separate programming language in itself, while C and C++ were dominating in the industry, was quite straightforward. Now, James Gosselin and his team were working with various mobiles and pagers at that time. When they had to develop applications to handle the messaging systems for these, it became quite a tedious task by using C and C++. So what did they do? They went ahead and created a new language itself. Must say, quite smart people they were. So one of the key features that made Java one of the most popular languages and is still the most popular language is that of its platform independence. Now when I say platform independence, you need to understand a key term here, that is write once and run everywhere. Now what do I mean by write once and run everywhere? In Java, once you have written your application, you can run it across any device, any machine that supports a Java environment. All you need to have to run a Java program is to have a simple Java environment present in that device, and then you can go ahead and run your Java application. Now, Java in itself is not just a programming language, it is also an operational platform. Now, when I talk about the Java being an operational platform, what basically means that Java gives you this simple virtual environment through which you can run the various Java programs. Now, this virtual environment, once you have added to your device or your machine, then you can, without any hassle or any problem, go ahead and run a Java program. Now, with this, I hope you've got a simple understanding and introduction to what is Java. Now, to give you an understanding of how Java grew throughout the years, let's look at the history of Java versions. Now, the first version of Java again was released in early 1996 and it was called Oak at that time. But then again was completely renamed to Java because of its favorability. Now, throughout the years till 2014, you have 8 versions of Java that were released, and the next version, Java 9, is also going to be released in July of 2017. Now, there was a lot of progress that happened throughout the different versions of Java, but we're not going to go in depth with respect to that. So what we're going to do now is we're going to address the biggest question that all of you may have, that is, where is Java being used? Now, to help you understand this, I'm going to discuss one of the most popular domain as well as one of the key factors which led to high demand of Java developers, and that domain is the Android domain. Now, we are all familiar with Android. It is an operating system that was released by Google. But how many of you know that the Android applications as well as the Android operating system in itself make extensive use of Java as part of it? Now, even the Android operating systems are built using core Java and still now use the various APIs that Java has to offer. Again, when you see with respect to the various Android applications, they are completely written using Java as their programming language. Now, to give you even a broader perspective, I have just selected 8 of the most influenced domains by Java. Now, don't misunderstand that these are the only domains which use Java. Java is used pretty much everywhere, starting from your phone till your set-top box to satellites as well. Now, we'll discuss about each of these domains and how they make use of Java. To start off, let's talk about the most popular and trending technology presently, that is the big data technology. Now here as of most of you would have heard, Hadoop is the most preferred framework. Now, Hadoop framework was extensively developed using Java and still makes use of various Java APIs as part of its features. You even have a key concept of MapReduce that you're going to be using in the big data domain. Then comes the stock market domain. Now here, the algorithms which help you understand which stock to buy are designed using Java. The applications in itself that is used in the stock market is built using Java as its core feature. Now the next domain is the scientific and research community. Now all of you are quite familiar that in the scientific and research community, a lot of calculations are going to be performed, and the numbers on which these calculations are going to be performed is going to be very huge. Now, when you're using an application to perform these operations, this needs to be highly powerful, it needs to be highly scalable, and needs to be precise. And in that field, Java is one of the most preferred language to build applications. So most of your scientific community applications are built using Java as part of their code. Then comes the IT domain. Now, IT is the domain that hires most of the Java developers. On a daily basis, you have close to 50 million applications developed using Java as part of its code. Now, this is not a number that's going to reduce any day, and therefore this in itself should give you an idea of how much job opportunity there is once you have grasped Java completely. When you come down to the banking domain, your transaction processing and your transaction management involves Java as part of its security feature. You're going to be using various components of Java to achieve your security feature there. Finally, when you come down to the retail domain, when you go down to a supermarket, the billing application that you see there, that also is developed using Java as part of their code. Again, your financial domain, there your server-side applications, that is a heart of a financial service. That extensively is written using Java itself. Now, with this, I hope you've got a simple understanding of how Java is going to be used across different domains. But again, coming back to my main point, that is Java is used everywhere. So you can consider Java to be a wide ocean that is spread all across us. But don't think of it as a bad way. Think of it as an opportunity for you. When Java is spread across so many domains, when it's present all around us, just imagine how much job openings, how much opportunities it can bring for you. And that exactly is what we're going to ensure as part of your learning. So till here, do any of you have any questions with respect to what is Java and where it is being used? So Ayushi is all clear, Emily says understood, so does Rachel, Shruti, Varun, Deepak. That's great to see, guys. Again, I'm going to emphasize that if at any point, if you have any doubts or if you do have any queries, put it across to me immediately so that I can clarify it then and there itself. Now, moving forward, let's look at some of the key features that made Java one of the most popular programming language. Now, these are the 8 key features that Java has to offer. Now, these are also referred to as the buzzwords of Java. And this is basically because when Java was introduced in 1995, there was a white paper written on it. Now, in the white paper, these were the main concepts that was focused on, and that's why they are referred to as buzzwords of Java. Now, we'll be talking about each of these features one by one. We'll start off with the simple feature. Now, Java is one of the most simple as well as fundamental programming language that anyone can pick up. And trust me guys, Java is so simple. At the same time, the possibility of what you can develop using Java is infinite. Now, compared to the other fundamental programming languages like C or C++, one of the key features that I like with respect to Java is that the concept of memory management is abolished here. That is, you do not need to worry about the pointer concepts that you may have heard of in C or C++. Java completely takes care of your memory management here. So automatically everything is done by Java here. Again, moving forward to the next feature, that is portability. Now, we've already discussed of how Java is portable, but to give you a better understanding, let's say you're developing an application in a Windows system, but your client is going to require to run that program on a Mac machine. You do not need to worry about that. As long as he has a Java environment set up in his system, the code will be optimized to his system and it can be run without any problems. Now, this is not just between Windows and Mac. It could be any operating system. It could be a Linux operating system like Red Hat or Unix, and your Java code would run across all these operating systems. Apart from that, your Java program also would not bother about your configuration of your system. It will optimize itself to meet the hardware requirements of that system. Now, we've already talked about how Java is an object-oriented programming language. Now, there are mainly two styles of programming language. You have your procedural style and object-oriented style. Java follows an object-oriented approach. Here, everything is an object. Starting from the variables that you'll be using to the operations that you're going to be performing are going to be done through objects. Okay, so I have my first question here. Emily is asking me, what do I mean by procedural style and how is it different from object-oriented programming style? Now, Emily, you need to understand few things here before I go into that. Now, basically, these are two approaches that the programming languages follow. Now, when you look at a procedural oriented programming, there basically you follow a top-down approach. That is, let's say you have certain sequence of operations that you wish to perform. In a procedural oriented programming, there you'll be executing each of them one after the other. But in an object oriented programming style, if you wish, you can perform them one by one, or if you want, you can even execute them simultaneously. The order does not depend on a top-down approach here. Basically, whichever is important will be executed first. Again, when you talk about the procedural style, there mainly the sequence of actions is given importance. But in an object-oriented programming style, here you're giving more importance to the data on which you're performing these operations. So with this, I hope you've got a simple understanding of how they're different and what each one is. So any other questions? Okay. So moving forward, let's look at the next feature, that is the secure feature. Now, when we talk about security, it's always a concern that when you're running an application from someone else, will it corrupt my data? Will it affect my data? Will it take some of my data and give it to someone? But with a Java application, you do not need to worry about that. Java basically has this sandbox that is present inside your virtual machine, which is an isolated environment. So what I mean by isolated environment is, what happens is your Java program is running inside a virtual machine which has no access to your actual machine's hardware. Therefore, in itself, it prevents the access of the application to your hard disk and your data is completely secure. Again, here the concept of memory management also comes in, where you do not need to worry about how the memory management takes place. That is completely managed by Java in itself. After that, we have the distributed feature. Now, there are mainly two things that you need to understand when we talk about the distributed feature of Java. The first is that once you've written a Java application, then you can go ahead and distribute it to anyone who wishes to run the application, as long as they have a Java environment on their device. Now, again, as I've told, this device could be from your setup box till your high performance computer. As long as they have a simple Java environment present in their system, they can go ahead and take your application and run it. Apart from that, Java has this unique feature known as remote method invocation. Now, let's say you're going to give your user a program, but that program requires a specific method inside another program. Now, this becomes a hurdle while you're executing a program because there's a certain dependency that is not met. But through the RMI, it is achieved where you can remotely execute that method that is present on another system. Now, this system could either be connected locally or it could be connected even through your internet. Now, don't worry too much about what the RMI is. We'll be talking about it in our upcoming sessions. But with this, I hope you've got a simple understanding of the 5 features that we have discussed. Now, moving forward, let's talk about the dynamic feature. Now, Java is a highly dynamic program. The reason that I'm telling you this is because there's a lot of dynamic detailing that comes in before you execute that program. Now, if you go back to our portability feature, I told you how your Java program, once written, can be run on any system. This basically is because of its dynamic feature, where all the execution environment details is only taken just before you run that program. This in itself decreases a lot of dependencies on that program and makes it highly dynamic as such. Then comes your robust feature. Now, there are two concepts here that you need to be clear of. The first is that every program that you write, that is checked before you compile the code as well as before you run it as such. So a quality check is always ensured before you compile it as well as before you run it as such. And the second main feature is that Java takes care of memory management. Again, here it checks about your memory of your system, then correspondingly allocates the memory for its required variables and operations. Finally comes your Java's high performance feature. Now, You've already seen how Java is used in different domains. Even the scientific community, where you're dealing with huge amount of data, makes use of Java extensively. That in itself should have given you a simple idea of how Java is achieving its high performance. Now, there's a key term here that you need to be aware of, that is bytecode. Basically, the Java code once you've written will not directly be converted to a Java application as such. First, it's converted to a bytecode, and then this bytecode is converted to your Java application when you want to run it. Now, this bytecode is something that can scale as well as adjust to your system configuration. Now, through this, you're going to achieve high performance. So, a Java application may run differently on a system with low configuration and may run differently on a system that has high configuration. Always the performance is kept in mind, as well as the other features of Java. Now, any questions still here with respect to the different features of Java? Okay, Varun is asking me which will have more preference, performance or memory management. Now, Varun, by default both would have equally high preference, but then again you can change it as per your requirement. Let's say you have a device which has low configuration, then you can configure your program to be more favorable to memory management. But let's say you want to achieve high performance, then you can configure it to meet the high performance standard. Was that clear, Varun? Alright. So, since there are no more questions, let's move forward to the next topic, that is Java environment. Now, we've talked about how Java works as an operational platform, but we've not gone in depth with that, and some of you may still be fuzzy on how you're going to run a Java program on your system, and this concept will help you clarify that. Now, the first thing that you want to run any Java program is a Java virtual machine. This is not an actual machine, it's just an abstract virtual machine on which you're going to be running your Java program. So as long as you have a Java virtual machine present on your system, you can go ahead and run a Java program. You need to have the JVM present on that system. Now this is basically in case of a simple application. But let's say you're going to develop a slightly complex program that uses different features of Java. Then you're going to need the second component, that is the Java runtime environment. This basically is an extension of the Java virtual machine, but you're going to have various classes and libraries in which all your features are present. So if you're going to execute a complex application, then you need to have the Java runtime environment. But again, last but not least comes the most essential component for a developer, that is the Java development kit. This basically is again an extension of the Java runtime environment, but here you'll also have the development tools. So in case as a developer, if you want to write a Java program, if you want to develop Java applications, then you need to have the Java development kit present in your system. So are you clear with respect to the different Java environments available? Okay, so Shruti is clear, so is Rachel. Deepak is also clear. That's great. Now moving forward, let's try to understand how does Java work. Now once you've written your Java code, then how do you convert this Java code to your Java application? The first thing that you're going to do is that you're going to give it to a Java C compiler. Now this will be present in your system itself. When you compile the program, a Java C compiler is called, and that will convert your code to a class file. Again, when I say a class file, this is a bytecode. So basically it's your intermediate file. Now, one key feature that you need to understand about the bytecode is that not anyone can read this code. So through the bytecode, you're not only achieving high performance, but you're also ensuring the security of your code. Now this basically is an intermediate file. It is neither similar to your high-level language, nor is it similar to your low-level language. And therefore it ensures both security and high performance as such. So let's say you're working for an organization, then what you're going to do is that you're going to go ahead and create your Java source code, then you're going to give it to your Java compiler, and then you're finally going to get your class file. Now once you have this class file, you can go ahead and give it to your client. He will neither be able to see your code, but at the same time his requirement for the application would also have met. But once he has the code, how will he be able to execute? And that's exactly where your Java virtual machine comes. Here you have a Java interpreter as well as your JIT compiler. This basically will translate your bytecode to an object file. An object file basically is a file which you can go ahead and execute, and once you've executed this code, you can see the output. Okay, so I have another question here from Shruti is asking me what is a compiler and what is an interpreter. Now, Shruti, the basic functionality of both a compiler and an interpreter are the same. They check if there's any error present in your code. But how they differ is that a compiler completely reads your code and gives you all the errors present in your code. But at the same time, what an interpreter does is that it reads the code line by line and checks if there's any error. At any point, if it meets an error, then it returns the error and does not process further. So until you have cleared that error, your Java interpreter will not move ahead. So are you clear, Shruti? Alright. Now to give you a little more detailed understanding of how this works, let's look at the diagram here. Now we've talked about the first half of this operation where you have your Java source code which is then again sent to a Java compiler which will change it to a bytecode. That is a .class file. Once you have your .class file, that is the bytecode, then you can go ahead and transfer this Java bytecode either locally or through a network. Now in the runtime environment, that is the environment where your customer wishes to execute this program, you basically have three different components. Now your first component is the class loader. Again, when we talk about class loader, this basically loads all the dependencies that your program requires. Then comes your bytecode verifier. Now the main objective of the bytecode verifier is to ensure that the code that you have written has not been tampered with. Now again, this could be something that would happen while you're transferring the file, or someone would have purposefully changed your code, and your bytecode verifier always ensures that your code is the same that you had written before you compiled it. Now once your bytecode verifier has checked and ensured that your code is correct, then this code is passed to your Java interpreter and your JIT compiler, which will then translate it and give it to your runtime system. Once your runtime system has this code, then it will give it to your operating system, which will then go ahead and give the details to your hardware. So I hope with this you've got a complete understanding of how your Java code works. Okay, Deepak is clear, so is Varun, Shruti, Rachel, Emily. That's great to see. Now, enough of theoretical knowledge. Let's go ahead and first install Java on your system. What you need to do is that you need to download JDK, that is Java Development Kit, not just Java. When you search for Java and download it, it basically is your Java runtime environment. So I'll just show you how it's done. So all you need to do is go to Google and search for JDK download. So here you can go ahead and click on the first link, and this will direct you to the Java Development Kit download page. So here all you need to do is click on download, which will redirect you to the download page, and here you can download your Java Development Kit according to your system configuration. So if you're using a Linux machine or if you're using a Mac, you can choose the corresponding version and download it. Now the installation of Java is quite straightforward. All you need to do is just keep clicking next, and once you're done, please let me know. In case if you're facing any troubles, also do let me know so that I can help you debug your problems. That's great. So now that all of you have installed Java Development Kit on your system, comes the most important part, that is setting the path of your Java environment. Now there are basically 5 steps that you need to follow. Let me show you how it's done. Now you can follow the steps in case if you're using Windows 7 or any later versions as well. So once you're inside your My Computer, just right click and then go to the Properties option. Here you have an option known as Advanced System Settings. Just click on that and you will get a pop-up. Here at the bottom you have an option that is Environment Variables. Once you click on that, you'll get your next pop-up, and here for most of you, you may have to add a new variable, but I already have a variable. So what you need to do is click on New, and then you need to specify the variable name to be path, and then you need to give the location of your JDK. Now in case if you do not know the location of JDK, let's go back to My Computer. By default your Java Development Kit is stored inside your C, Program Files, Java, JDK and bin. So take this complete path, copy it, and here specify name to be path, and then give the path. Now I've already configured it, so I don't need to reconfigure it, but in case if you already have a path file, then just double click on it, go to the end, put a semicolon and then give the path. So let me know in case if any of you are facing any troubles, I'll be able to assist you. Now the final step to check if your Java environment has been configured successfully is you need to run a specific command. So just open your command prompt and then just type javac. Now if you get the following message, then you have correctly set your Java path, but in case if you do not get this message, do let me know so that I'll be able to assist you. Alright, so now that all of you successfully installed Java and configured the Java path variable, let's write our first program. Now to write your Java program, you can use any editor. I'd recommend Notepad++. So you can open your Notepad++ and you can just copy the following syntax. So start off with the following syntax. Now this basically is your syntax for your hello world program. Basically what you're doing is just you're printing hello world in your screen. Now don't worry about the structure, we'll be talking about that as well, but what you need to understand is that every code that you're going to be writing is going to be written inside a class. So here you can see inside my class I have this function that is public static void main. Now again, don't worry about these modifiers, but your void main basically is the first function that is always going to be executed. So anything written inside your void main would be the first statements that would be executed before any other statements would be called. And here to print any text or any data onto your screen, you're going to be using the following syntax, system.out.println. So this is a standard format that you're going to be following to print anything onto your screen. Now it's time we save this file. One thing you need to keep in mind is that whenever you're saving a Java program, you need to name the file with a .java extension as well as the name of the class should be name of the file, because these are standard processes that you need to follow. So since my class name is hello, I'm going to name it hello, and then I'm going to make sure it is a Java file type. So you have various file types present here, so select on Java source file. This will ensure that the extension is .java. Click on save. Now we need to execute that program. Before you execute that program, launch your command prompt, and there are few things that you need to do. Go to the directory where the Java file is present first. Now here you cannot directly execute this file. What you need to do, as we have seen earlier, is that we need to create a .class file. Now let me just show you how the directory is at present. So I have my hello file present here. Now the first process, if you remember earlier, was that we need to give this Java file to a compiler to get the .class file. Now to provide the file to Java compiler, use the following syntax. javac followed by the file name, and then just click on OK. So here you have provided your file hello.java to Java compiler. Now if you go back to the location which had the Java file, you can see a new file is also created. Let me just enable the extension so that you guys are clear. So you can see I have one hello.java file as well as I have a hello.class file. So basically my original source code, which looks like this, has been passed to a Java compiler, and let me show you how the bytecode looks like. Now here you can see this file contains various symbols. It has specific characters as well, but to a user it is not something through which he can identify what my code does or what my code looks like. So therefore your code becomes highly secure, as well as your portability feature is also achieved here. Now finally, to run this code, what you need to do is specify Java and then the .class file name. So hello, and just click on OK. You don't have to specify the extension here, and you can see hello world is printed. So please go ahead and try this code, and in case if you're facing any troubles or you're not sure on any of the steps, do let me know so that I'll be able to help you. Now this is a basic way of creating and executing your Java program. But let's say you're working with different files. It becomes a huge problem for you to maintain these files as well as organize them. Therefore, what you're going to do is that we're going to be using an IDE, that is an integrated development environment, where you can both create your file, you can compile it, as well as organize your various files. Now, the most popular and the most widely used IDE is the Eclipse IDE, and I'd recommend that you go ahead and download the Eclipse IDE from their website eclipse.org. Let me just show you how it's done. So just go to eclipse.org, and here itself on the home screen you have the download option. Now, the most updated version of Eclipse presently is Eclipse Neon, and this is the same thing that I would request you to download. Now click on download packages. Here I'd recommend you to download Eclipse IDE for Java EE Developers Edition. So all you need to do is specify the version of Windows that you're using and it'll automatically download. Now in case if you're using Linux or Mac, all you need to do is just click on this link, and to your right you have the option for various operating systems. So go ahead and download Eclipse for your system, and the installation process is quite simple. This is basically a zip file. Once you've extracted this, you can directly launch the Eclipse from that folder. Okay, so now that all of you installed Eclipse on your system, let's go ahead and launch Eclipse. So just double click on it. So this is basically the welcome page. Just close this, and we need to start by creating a new project. Now, when a project basically is a collection of all the codes that you're going to be writing, so it's always suggested that when you're writing codes that are similar to each other, let's say you're working on the first module, then I recommend you create a new project for the first module. Now, to create a new project, what you need to do is just click on the new option present here, and then you have the option of Java project. Click on it and click on next option. So you need to specify the name of your Java project. So what I'm going to do is that I'm going to call it What is Java. Once you're done on that, just click on finish. So you've created your Java project file. Now if you open that, you have basically two elements present here. You have your source file as well as your Java runtime environment. Now just right click on your source file and then go to the new option here. Here you need to create a class. Now as I've told you, everything in Java, every code that you're going to be writing in Java is going to be present inside a class. So what I'll do is I'll just show you how easy it is to execute the same hello world program using Eclipse. So let's call it hello and click on finish. So I'll just copy the code I had written earlier. Just save it. You can do that by pressing Ctrl S. Then it's time to execute this program. So you see the plus option here. This is for running your code. Just click on it. And you can see the output below here. I have hello world. So you can go ahead and try running the same program that you had run earlier using Eclipse. I hope you've understood how easy it is to run a program using Eclipse. Okay, Varun is asking me, can I use NetBeans instead of Eclipse? Okay, to those of you who are not aware of what NetBeans is also an IDE that is provided by Oracle. Now, Varun, you can use it, but I'd again recommend that you go ahead with Eclipse, because this is the IDE that most of the industry works with. So you will also get an exposure using this IDE before you move into your job role in the industry. As well as it's easier for you to work with Eclipse when you compare with NetBeans. Alright, so now that all of you have installed Eclipse and understand how easy it is to program using an IDE, let's begin deep diving into Java, and the first thing we'll be discussing is the various data types that are present in Java. Now, when you look at each of these primitive data types, there are various sub-data types as well. Now, when you look at integer, there are basically 4 subtypes under integer itself. You have short, you have long, you have byte, and you have int. Under float, you have double and float. Character and boolean have only one corresponding. But you may be wondering what each of these are used for. So to give you a better understanding of what is used for when, so let's look at our next slide that gives you an understanding here. Now, let's say you're going to be using a byte. Now, as the name suggests, a byte uses only one byte of memory location, but the problem here is that using a byte you can store a value only between -128 to +127. If you try to store a value that is more than that, then the correct value is not stored. But at the same time, to solve your problem, you can use a short. Now a short can store a value that is between minus 32,768 to plus 32,767. So this is a huge range, and if you want to store a number between this, then you can go ahead and do that using a short variable. If you want to go beyond that, then you're going to be using int. Now int is something that can be used to store a numerical value that is greater than short. Now generally we make use of int rather than using byte and short, and in case if you want to store a large number, then only you'll be using the long variable. Now here again the difference between using float and double is the range of numerical value that it can store. Generally it's preferred that you use double because it gives you a more precise value as such. When you come down to character, it can store a value that is between 0 to 65,536. Now one thing that you need to understand here is that here what you're going to be actually storing is the ASCII equivalent of every character that you're going to be saving. So let's say you're going to be using A, then the ASCII equivalent of A would be actually stored inside a character variable. Finally, you have your boolean that is used to store true or false. Now one thing you need to be aware of is that a boolean just uses 1 bit of memory because it needs to only store true or false, and this can be done using a 0 or 1. Therefore it requires only 1 bit of memory. So are you clear with respect to what each of these data types are used for? Okay, I've got a confirmation from Emily. Rachel has also given me clear. Okay, let me go ahead and show you how you can initialize and create variables of these data types. Let's go back to our Eclipse, and here let me create a new class file. Now to create a new class file, you can just click on the C icon present here. It will create a new class file here itself. So let me call it data types. And one thing you need to do is that you need to check this option of public static void main. So this automatically creates a public static void main inside your class. So now let's go forward and let me show you how to declare a variable in Java. Now coming back to our Eclipse here, now let's say you want to declare an integer variable. So again, you're familiar with the 4 different types of integer that we have, but as I had said, generally if you want an integer variable, it's suggested that you use int. Now once you've called int, then you need to specify the name of the variable you want to create. Let's say I'm going to create a variable num1, and then at the end of every statement you need to put a semicolon. Okay, this basically means that this is the end of that statement. Always remember, at the end of every line put a semicolon. If you don't, Java will in turn give you an error. But again, since you're using an IDE here, you basically will see that across the line itself. So if I remove this, you can see here an X present. You can see an X present here. So this is basically telling me there's a syntax error and to insert a semicolon to complete the block statement. So again, these are some of the key advantages of using a IDE. So I have an integer num1. Then let's say you have a floating variable num2. So now let's go ahead and create a second variable which is of a floating type, but again, as I had said earlier, to be more precise, let's use a double here. Let's say num2 and then again semicolon. So here what we have actually done is that we have completed the declaration of a variable. Along with the declaration of that variable, we have also specified which type of variable it is. Now comes the essential part, that is the initialization. Now initialization basically means that you're going to assign an initial value to that variable. Now this is something that will definitely come into handy when you want that variable already to have a value while you're using it. Now let me give you some examples. Let's say you're going to be using a float variable called pi, and as you all know, pi is going to have the value of 22 divided by 7, that is 3.14. So that is a huge number. So instead of declaring it as part of my program itself, when I'm creating this variable, when I'm declaring this variable itself, then itself I can initialize it to a value that I want. So let's say I'm going to initialize my num1 to be equal to, let's say, 5. Now here what I'm doing is basically I'm declaring as well as I'm initializing. Now if you don't want to do it here, then you can also write it as part of your code where you can say num1 equal to 5. So here again I have initialized it to a fixed value. So are you guys clear till here how to work with variables? Okay, Varun is clear, so is Emily, Shruti, Ayushi, Deepak, that's great. Now let's say for num2, what I'm going to do is let's say num2 is equal to 22 divided by 7. Now again, your arithmetic operators will work here as well, but let's not go into with respect to these operators. We'll be talking them in our upcoming slides. But for now, just understand that 22 divided by 7 is going to be stored in my num2. Now I need to print num1 and num3. So if you remember our previous statement, for printing we had to type system.out.println. But in Eclipse there's a shortcut for this. Just type sysout and then press Ctrl space. This, your sysout gets automatically expanded to system.out.println. So here just say you want to print num1. Similarly, let's type num2 as well. So now let's go ahead and run this program. Now again, to run this, always save the program. That is, press Ctrl S and then right click and select Run as Java Application option. Or you can go to the Run option present here and directly execute this program. So just click on Run as, and there you have it, our output. So one is storing 5 and the second is storing 3.1428571 and so forth. So are you clear with respect to both integer and floating values? So Divya is asking me, instead of saving num1 as 5, what will happen if I save 22 divided by 7? Okay, let me show you that as well, Divya. So I'll just change it here. 22 divided by 7. Let's go to Run option here. So just click on Run and then click on OK. And here you go, you have the output. So I'm performing the same operation and storing it in two different variables, but because the difference in the data type, the different values are being stored. One is saving it as 3.1428571 and the other is just storing 3. So I hope this clears your doubt, Divya. Alright, not a problem. So any other doubts? Okay. So before we go ahead, I'll just show you how to declare a character and a boolean value. So again, for character, it's char space the name of the character, let's say yes equal to. Now here what you need to do is you need to specify the character in single quotes. So just use a single quote and specify what character you want to save. So let's say y and a semicolon, and that's it. So you've declared a character, and then comes boolean. So for boolean you have to type the complete boolean, then the boolean name, let's say output equal to, then you need to specify either true or false. Let's say false. So you can see here false has been highlighted. So this basically means everything that you see in purple here, basically these are keywords. So again, when you talk about keywords, these are specific words that have a reserved value in Java. So you cannot assign a specific value to a reserved keyword. So let's say you're declaring a variable name, make sure you're not using a name that is being used by a keyword, because what happens is that they have specific values already as part of them and you cannot overwrite it. Okay, now with that, let's go back to our presentation. So we've seen the various data types that are present in Java. Let's move forward and talk about the various data operations that you can perform in Java. Now when you talk about the various data operators, there are mainly 4 different types of operators. You have your arithmetic operator, you have your unary operator, relational operator, and logical operator. So we'll start off by talking about the arithmetic operator. Now here you have your normal operations like addition, subtraction, division and multiplication. Apart from that, you have a new operator, that is the modulus operator. Basically what the modulus operator does is that it performs a division. But rather than giving you a quotient like a normal division, here you get the remainder of that division. Let's say you divide 5 by 3. Normally you would be getting an output of 1. But here what you would be getting is the remainder, which is equivalent to 2. So are you clear with respect to how the modulus operator works? Sure, Stephen, I'll just show you the output as well. So let me declare another variable as num1. So let's say you have multiple variables of a same type, then rather than writing the data type, then the variable name, data type, then the variable name, what you can do is in a single line, you can specify the data types and then following that the variable name. So let's say num3, and here what I'm going to do, num3 and num4, let me put it num4 also. My num3 is equivalent to 5 divided by 3. My num4 is equal to 5 modulo 3. So for performing modulo operation, you need to use the percentage symbol here. So I'll just copy these two statements Instead of num2, let me make it num3, and I'll make it num4. Now, one thing you guys need to remember is that let's say you want to comment in Java. So for that, all you need to do is use backslash. So when you use backslash, everything that follows the backslash in that same line is considered to be a comment. So this means that every statement that is going to be present in that same line is going to be considered to be a comment. Now you need to understand that this is just a single line comment. Now if you want to perform a multi-line comment, then all you need to do is that instead of using double slash, what you need to do is a single slash, then you can use a star operator, and then at the end point where you want your comment to end, there use a star followed by a slash. So this basically means that everything enclosed between this is a multi-line comment. So just save the program and then let's execute. So you can see here the output difference. I'm performing the same operation but I'm getting different outputs. Now don't go by the value. Now since num3 is an integer, you're not getting the decimal value here, but I hope you can differentiate between both. So one is giving me the quotient, the other is giving me the remainder. So are you clear now, Stephen? Alright. So the next set of operators that we are going to be talking about is the unary operator. Now again, when you talk about unary operator, there are basically two operators. You have your increment and then you have your decrement. So what basically you will be doing using an increment operator is that you will be incrementing its current value by 1. Or remember, you're incrementing the value by 1. But there are two ways to perform both increment and decrement operation. If you look at the slide here, it talks about the same. So you have this concept of pre-increment and post-increment. So if you're writing the variable name and then following that you're mentioning the increment operator. So to perform increment you need to use two pluses. Again, there are basically two kinds of increment and two kinds of decrement. You have your pre-increment and you have your post-increment, and that's exactly what is discussed here. So you see here you have the variable name and then you have the increment. So this is a post-increment. What you're basically going to do here is, let's say I is equal to 5. If I use this statement and print it, what is going to be my output? Can anyone guess? Okay, so I have a lot of guesses here, but I'm not going to answer this right now. We'll just talk about post increment and then we'll execute this and see who's right. So here what you're basically doing is that you're specifying the variable name and then you're specifying the increment operator. So this is a post increment operation. So what happens here is that you're first going to use the current value of the variable and then you're going to increment it by 1. Similarly, when you talk about pre-increment operator, there what happens is you're going to first increment the value of the variable and then only use it. Now let's say your value of I is equal to 5. Now who can tell me the correct value for I plus plus and plus plus I? So both of these statements are executed one after the other, I plus plus and plus plus I. Okay, so a lot of you have made different guesses. Let's see who's right. Let me just execute these two statements. I'm going to use another variable I equal to 5. Print I plus plus and plus plus I. Anyone wants to change their answers? Alright, so let me just run this. Run as Java application, click on OK. You can see here 5 and 7. So I'm going to print the current value of I equal to be 5. So before I start my print statement, what actually happens is that it checks the current value of I. So it's found to be 5. So what it does, it goes ahead and prints the value of I equal to 5. But then what happens is the increment operation comes. So then it is basically telling the system that it needs to increment the value of 5 to 6. But when you come down to the next statement, so here what happens first itself is you're encountering an increment operator. So first itself you're incrementing the value of I from 6 to 7. So directly it is printing 5 and 7. So are you clear with respect to the increment operator and how prefix and postfix works? Okay, so I have a question here from Deepti. She's asking me where will I be using these unary operators. In Java, under the concepts of loop, we have a loop known as for loop. So there's always a constant incrementation, and there you'll be mainly using the increment operator. Similarly, instead of increment operator, you can also use the decrement operator, but throughout your program, wherever you want to increment a value. So let's say you're working with multiple employee records and the employee ID has to be increased by 1 every time, correct? So there you can use an increment operator. Alright, so Deepti is clear. Any other doubts? Yeah, similarly the decrement operator also works. Let's say minus minus, save it. Any guesses to the answer? So let's run this, right click. So the output is 5 and 3. So most of you have got the answer correct. Then the next type of operator that we'll be discussing is relational operators. Now, relational operator, basically what they do is they check the relativity. So you have your greater than equal to, then you have lesser than equal to and not equal to operation. Now in Java, when you put a single equal to, it is considered to be an assignment operator. That is, any value or any expression to the right of equal to should be assigned to the variable present on the left of the equal to operation. But let's say you want to compare two variables, then you're going to use the double equal to operators that will check their two values. Now let's look at each of the relational operators. Now when you perform a greater than operation, the result is true only if x is greater than y, else it returns false. So this basically gives you a boolean value as the output. All your relational operators give you a boolean output. You need to remember that. Similarly, greater than equal to, if your value of x is greater than or equal to y, then it returns true, else it returns false. So here you have an additional equal to value. Same for lesser than and lesser than equal to. Now comes your equal to operation. Here you get the output to be true only and only if both values are equal. And finally, if you want to check if both values are not equal to, you can use an exclamation mark followed by equal to. Now an exclamation mark is considered to be not in Java. So when you say not equal to, it checks both the values, and if they are different, then you get an output to be true. So are you clear with respect to the relational operators? Okay, so now that you guys have understood relational operators, let's go back to our Eclipse and try out something now. Now, firstly, as we know, relational operators give us a Boolean output. So what I'll do is I'll create a new Boolean variable, let's say output, and give it a default value of false. Now let's try out some of the relational operations. So I'll just extend this comment section till here, and then let's say output is equal to 25 greater than 50. Now if I need to print output, let's check out the corresponding output for it. Let's save this and let's run it. So you can see the output to be true here, and if you print output before this line itself, you can see the change in its value. So again here, let's just save, let's change this so that you can also understand how the value is changing. I'll just print output before I perform the relational operation, and I'll print it again once after it. So if you save it and run it, you can see you're getting false to be the first output and true to be the second. So by default it had false value, but after I perform the relational operator, it is storing a value of true. Same, let's say if I check if both are equal to each other, and then if I rerun this, and then you can see both output to be false. Now this is something that will extensively be helpful for you while you're working with different variables and you're not quite sure on the values that each of them stores. Okay, now let's say I'm going to check if num1 and num2 are the same. So what I'll do is I'll just say num1 equal to num2. So as we have seen earlier, num1 is storing 22 divided by 7 and num2 is storing 22 divided by 7. So basically they both should have the same value, and if you rerun this, it gives you the value to be true. So especially when you're working with variables and you're not quite sure on the value that they assume, your relational operators are really helpful. Now are you clear with respect to how relational operators work? You can try out if they're not equal to as well, if you just make the small change here and put an exclamation mark. This is for not equal to operation. If you just save it and run it, you can see the value has been changed. So again, any doubts with respect to relational operators? Okay. So the last type of operators we'll be talking are logical operators. Now logical operators are quite useful when you're working with multiple conditions. Now usually your logical operators are combined together with your relational operator, And to help you understand what are the logical operators, let's look at the slide here. There are basically two types of logical operators. You have logical and you have logical OR. Let me just highlight it here. This is your logical and this is your logical OR. Please don't mind the bad handwriting. Okay, so how do they differ? That's what you need to understand. Now, your logical AND actually compares the left and the right operand with respect to their values. And if both of them are found to be true, and only if both are true, will it return a Boolean value as the output to be true. Okay, again, same like your relational operators, logical operators also give you Boolean value as the output, but only in case if operand 1 and operand 2, that is operand to the left and operand to the right of the logical AND, are true, then will you be getting the output to be true. But at the same time, when you look at the logical OR, how it differs from the logical AND is that if at least one of the values is true, then it returns the value to be true. So in case both are true, you have true, and only in case if both operators are false will you get the output to be false. Now, you may be wondering where these operators are used. Again, as I had mentioned earlier, you use them with your relational operators. Now, let's say you have multiple conditions and you're putting that inside a conditional statement. Now, only and only if all the conditions mentioned are true, would you want to execute the code inside the conditional statement. In that case, you will be using a logical AND. But let's say if at least one of the conditions is true, then you can go ahead and use the logical OR operator. So are you clear with respect to the logical operators, logical and logical OR, and how they're different from each other and when to use them? Okay, Deepti is clear, so is Adam. I've got a confirmation from everyone else. That's great to see. So with this we come to a conclusion about the different data operators in Java. So let's move forward and talk about another very fundamental and important concept, that is functions in Java. Now, what is a function is the first question that would come to any of your mind, and let me put it very simply. A function basically is a block of code. Okay, the purpose of the code inside is to reuse it and reduce the code redundancy. But you may be wondering what exactly does that function do. So each function has a specific purpose. Now let's say you want to add 10 values and this has to be done maybe 5 times. So rather than writing the complete code for adding the value 10 times, what you'll do is you'll just write a function that takes 10 numbers and then it gets called every time that you want to write it. Now how it works I'll be talking in the next slide, but what you need to understand is that functions are something that help you reuse a set of instructions used to perform a related operation. Now again, talking about the types of functions, there are basically two types. You have built-in functions and user-defined functions. Built-in functions are basically those functions that are present already in your Java packages, which you can use as per your convenience once you imported the package. To give you the most simplest example, your print statement is a predefined function that helps you put out an output to the screen. Now, let's say you want to perform a specific operation. Then you can go ahead and create a user-defined function. Now, when you look at the structure of a function, let's look at the example here. The basic syntax for a user-defined function is the modifier type, then the return type. That is what kind of output will be returned from this function, the name of the function or method. Now, don't get confused if I use method instead of functions. They both mean the same thing, and the parameters or the input that this function is going to take. After that, you have the set of statements or operations that you wish to perform multiple number of times. And here if you look at the example here, there's a method known as add. So it is basically a public static method which returns an integer output and takes two input, int a and int b. What it does, inside that you have a new variable int result which adds a and b value and returns this result. Now if you look at the image to the right, basically this is a division of the code. So again, your add function has been defined here. So these are your function parameters, this is the function definition, this is the function return value, and this is basically how you call a function. So you just use the name of the function, pass the parameters, and then it correspondingly calls the function. Now if it is returning a value, you need to store it inside a variable. If it is not, you don't need to do that. Okay, I have a question here from Deepti. So Deepti is asking me what happens in case my function does not have to return a value. Definitely, that's a very good question, Deepti. You've asked it at the right time. Now, if your function does not return a value, then the return type of that function will be void. Usually this is done for certain appending or changing with respect to a value, and in those cases you don't need to return a specific value to the user. So Rather than explaining it here, let's go back to our Eclipse and work this out. I'll create a new class, let's say I'll call it function test. So again, we have a new class file as well as a main. Now again, your main is one of the best examples of a method, and main is the first method that gets executed when you're writing a code or executing a code. So always remember, execution starts from main, and main in itself is a function. So here you can see the modifier type, the return type. Your main does not return anything. The name of the function is main, and these are the parameters. What do we mean by string args? It basically is used when you're taking parameters from the console. Now let's go back. Let me create a new function here. Now what I'll be doing is I'll just show you a simple function that computes the Fibonacci series. So let's say public static. Now it's not going to return anything, so I'll say void Fibo, and it's going to take an argument of integer, let's say n. So who's not familiar with Fibonacci series here? Okay, so all of you seem to be familiar with Fibonacci series. So it starts from 0 and then it keeps adding the consecutive numbers. So what I'll do here is I'll declare three variables, int num1, num2, and let's say num3. So I have three numerical values here. So my num1 would be equal to 0 and my num2 is equal to 1. So this is how your Fibonacci series starts. So here let's say sysout num1, put a plus, and then we need to put a space here, so quote, I'll put a space plus num2. So I've printed the first two numbers of the Fibonacci series, and now what I need to do is I'm going to find the first n number of elements present in the Fibonacci series. So for this, what I'll be using is I'll be using a slightly new concept here. I'll be using a loop statement, that is the for loop. Okay, now don't worry what it exactly is. A loop basically helps you execute a certain number of statements for a required number of times. Now just look at the syntax and how it works out. We'll be talking about the loops in our next session. So let's say int I equal to 2, and my I has to be less than the value of n that is taken. Finally, you have I++. So this is what I was telling Deepthi, where we are using the unary operator. So this basically helps you increment the number of times the loop has to get executed. So what I need to do is I have printed the first number and the second number. Now I need to print the third number onwards. So in that case, my num3 becomes equal to num1 plus num2. Okay, I've identified these two, and now I need to print num3. I'll add in a space here, plus num3. Okay, now I need to update the value of my num1 and num2 so that the series gets updated. So who here can tell me what value should my num1 and num2 take? Okay, that's good, Sandeep. It has to take num1 has to become num2, num1 equal to num2, and my num2 should be equal to num3. So you're basically updating the value of number 1 and number 2 once we've completely printed number 3, and this will get executed continuously. Now let me create a new variable here, int count, and let's say count equal to 20. I want to identify the first 20 elements of my Fibonacci series. So here just call Fibo, pass count here as the parameter, and we're done. So let me just save this and let's execute this and see. Okay, so if you look here, you have the Fibonacci series printed for the first 20 elements. Okay, so what I'll do is I'll make a small correction here. I am changing my println to print, so that way it comes in a single line. Save it and rerun it. Then you have the first complete 20 elements of the Fibonacci series. So 0, 1, 1, 2, 3, 5, 8, 13, 21. So you can see here the previous two numbers are getting added and the next number is getting appended. So 13 plus 21 gives us 34. Similarly, 34 plus 21 gives 55, and so forth. Now let's say I want to find the first 100 numbers. So I'll update the value of count, save it, and let's rerun it. So this is the first 100 elements of the Fibonacci series. Now the reason that certain values are negative is because it is going beyond the range of integer values. So we have already discussed the data types and their range. So if you see here, this is more than the range of integers. So what should we do? Can anyone guess it? Correct, Sandeep. So the data type has to be changed to long. So we can change it here. I'll just save it and let's try rerunning it. So now here you can see the values of the first 100 elements of the Fibonacci series. So this is a consecutive order recording. So again, I hope this has also given you an idea as to why we need to use different data types for different numerical values. So any doubts with respect to what is a function, how to write a function, how to call a function in Java? Okay, Deepthi has given me a confirmation. So has Sandeep, Adam, that's great to see. Everyone's given me confirmation. Great to see that. So again, one thing I'd like to recommend is that you try out these codes simultaneously in the Eclipse so that you'll be able to understand it better while I'm explaining it itself. And even if you encounter any problems or any errors, I'll be able to assist you right away. So please make sure you're trying out the code simultaneously, and if you're not clear at any point, do let me know so that I'll be able to assist you. Okay? That's great. So moving forward, let's talk about the next and the final concept of today's session, that is object-oriented programming. Now, most of you would have heard of this key term, but you may not be quite clear with respect to what exactly is the object-oriented programming paradigm. So let's talk about that in detail. Now, the first thing you need to understand before you talk about object-oriented programming is what exactly is an object. An object basically is a collection of a data which is considered to be state in case of Java and methods or behaviors in case of Java that act on this data. Now, to put it in very simple terms, everything that you see around you is an object because it has a certain amount of data and there are certain amounts of behavior that it does. Let's take the example of us itself. We have a certain state. We have a name, we have our height, we have a weight. So this is what basically we mean by a state. And we also have a behavior. We talk, we walk, we run, we sleep, and these are some of the behaviors. In terms of object-oriented programming, anything that has these properties, that is, it has a state and a behavior, can be called as an object. Now here you can see the example of a phone that is being taken. Now, every phone has a specific size, it has a color, it has a shape, as well as certain behaviors like turning it on, making calls, sending messages, WhatsApp, internet management, your Facebook. So these are all methods that you're working around. So I hope you've got a simple understanding as to what an object is. Again, an object is anything that has a state and a behavior. So basically everything can be considered to be an object. Okay, but when you talk about object, you need to also understand what exactly is a class. Now a class basically is a blueprint from which objects are created. If you look at us, we are basically objects that belong to the human class. So in the human class, there would have been defined number of eyes everyone has, number of nose, number of hands, number of legs. So these are the certain common things that all humans have. On an individual basis, when you look at us as objects, we are slightly different from each other, but again there are a lot of common things which are present in the human class. Similarly, if you look at the example here as well, we are talking about the phone class. Now every phone is going to have a brand value, it's also going to have a battery power value, even a processor that it's going to be using. But what is the value for this? This is going to change from object to object. All the class is telling us is the object would have these corresponding states and each of them will have a common behavior as well. Now every phone is going to turn on, every phone is going to have a method that helps you call, a method that helps you send a message, but how they work may be slightly different, but they do have these methods. So all these methods can be defined in the class, which basically tells how the blueprint of the object is going to be. So are you clear with respect to classes and objects and their relationship with each other? Okay, I have a question here from Sandeep. Sandeep is asking me, can we have an object that does not belong to a class? That's a good question, Sandeep. To be very frank, no, we cannot have, but to help you understand better, we use objects to help us achieve a certain behavior or to have a certain idea of its state. So having an object that does not belong to a class becomes problematic because there is no generalization or an idea as to what that object can do. Are you clear, Sandeep? Okay, that's great. So moving forward, let's talk about the four core fundamental concepts of object-oriented programming, starting from inheritance. What do we mean by inheritance? Basically, inheritance is a mechanism through which we can acquire the properties and the behavior of a parent object. Now, let's take this example of phones present here. I basically have a simple class called as phone or mobile. Now in this class there will be specific methods defined and there will be specific values. Now when I have child classes, in this case I have an Apple phone, I have Samsung phone, I have a Google phone. They may slightly vary with respect to each other, but they always have all the triads present in the mobile class. Apart from having the triads of mobile class, they may have specific unique triads as well, but they always inherit the properties and the behavior of our parent class. So your parent class is called as superclass and the class which is inheriting these properties is called child class. Are you clear with respect to inheritance? So basically it's quite similar to your actual inheritance where you get something from your parents who have got that something from their grandparents and so forth. Now these things are basically common to you, but apart from these things you will also have some additional things. So that's how inheritance works. Clear here? Okay, that's great. Moving forward, the next concept is encapsulation. Now by encapsulation what we mean is basically it is a mechanism through which you're going to bind both your code and data it manipulates together into a bundle. Now, what do I mean by this is that I'm going to combine my variables and my methods and hide it from the others. Only an object of that class can go ahead and modify the data corresponding to that class. But if any other object tries to do this, it cannot access it or modify it directly. To give you a simple example, let's look at the image below here. Now, let's say I have a phone that has a fingerprint scanner. Now, unless and until I either press the fingerprint scanner or enter the password, I'll not be able to open that phone and make the required modifications or changes. This is the same thing that happens here. If anyone else tries to access it or modify it, he'll not be able to do that because he doesn't have the authorization. Same thing happens with our code as well. Only a method of a class can go ahead and modify the variable values. No other object or method from a different class can come and modify this, and this is possible only through encapsulation. Are you clear with respect to encapsulation? Okay, that's great to see. Now, the next concept with respect to object-oriented programming is polymorphism. What do I mean by polymorphism is that it is the ability for a variable or a function or even object to take multiple roles apart from its usual role. And I don't think there's a better example from apart from the image shown below here. The mobile phones that we use today has replaced the cameras, remotes, MP3 player, video source. It has almost to an extent even replaced the usage with respect to laptops as well. People are more convenient with working to the mobiles. So your single entity, that is your mobile, is taking up different forms here. It's acting as camera, it's acting as a workstation, it is acting as a music player. There are phones which has IR blaster that becomes a remote and so forth. Is it clear? Okay. And finally comes your concept of abstraction. Now abstraction is a very simple and straightforward process. It basically means that you're going to hide the implementation details from the user and only provide the functionality. Now if you look at the image below, you can see a phone that is getting a call from John Brown. We know that because there's a notification that comes on our screen that says there's a call from John Brown, this is his number, do you want to pick it up or do you want to hang up? But do any of us actually know what is the code or what is the program that is running behind which is managing this call? Absolutely not. So that basically is how you're hiding the implementation details from the user, but at the same time you're providing the functionality to the user to use it. So if I swipe right or swipe left, there would have been a specific code that would be written and that would get executed. What that code is not something I need to worry about. All I need to know is I can use this functionality to achieve this purpose. So any doubts with respect to the 4 object-oriented concepts? Okay, this is great seeing that all of you have understood up till here. Now we come to a conclusion of this session, and just to summarize what we have learned till here is we started off with an introduction to Java, then we moved on to understand why we need to learn Java. We even saw the various features of Java, we talked about the Java environment and how Java works, and from there we went on to talk about the various data types in Java, the various data operators, the functions, and finally the object-oriented programming concepts. Any doubts with respect to any of these topics? Anything that you're not clear with that you want me to repeat? Okay, since there are no more questions, let's go ahead and conclude the session. Hope you had a great learning. Have a happy weekend and thank you.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!